Python for Data 1 Unit 7, we're taking a look at loops. What I like to tell people is when you're first getting started, loops can be a little bit conceptually easy to understand, but a little bit harder to program, and you're not really sure when you're supposed to use them. So, hey, you don't have to use loops at all. Just you're going to get to a point where you're going to say there's got to be an easier way to do this. I'm doing the same thing over and over and over. You probably felt that when you were working on the IMU calculator with all the if then else's. This is a way to automate those processes so you're not having to go over and over and continue to do the same process. There's a couple different types of loops. There's a for loop and there's a while loop. Also, when you're working with loops, you're going to be kind of playing around with some ranges here, and you will typically be updating some kind of a list, and we're going to show a little bit on counting to control and work with your loops. There's a lot of different analogies out there that help you understand what a loop is. There's one that I came across years ago that I love, and it was a military guy who was teaching Python, and he said that a for loop is like when your drill sergeant says drop and give me 20. And so when you start the loop, your body's going down to do the push-up. And then as you come up, that's 1. And so you've gone through the loop 1 time, you go down again. And as you press yourself up, that's 2. Once you repeat this 20 times, the loop is over. That's a for loop. A while loop is when the drill sergeant says, drop and do push-ups until I'm tired. And so you go into the push-up, and as you come up, you look up to the drill sergeant to see if the drill sergeant is tired. And if they're not, then you go back into the loop again. Another way to look at this that I like is a city block. So this is a good one for people who have kids, but you can empathize anyways. And that is you have a baby that's crying, and sometimes driving them around the block of a neighborhood a few times, the baby will fall asleep. If you have, you picture a block and you're driving around once, if the baby is still crying, then you continue to drive around until the baby's done crying. So how many times do you go through that loop of the block is really dependent on when the baby stops crying. So that's a while loop. Whereas a for loop would say, hey, whether the baby's crying or not, I'm only going around this block 4 times. Okay, so we'll go ahead and take a look at this syntax down here. We can see that we've got the for, a container, we have an in, which is, kind of similar to SQL in that we're going to be doing a list that we'll be looking in of some sort. So we have some values here, and then we're going to do something. For this container here that's empty, we're going to be taking these values and putting them into the container. And how we're going to do that is we're going to do something down here that's going to manipulate these values and reload them into the container here. So here's an example. We've got for, we've got a container that's empty called color. We have a list here, red, blue, green, and we're going to make them uppercase and put them into this container. And each time it goes through, it's going to print. Here we go, red, blue, green, it's all uppercase. If we actually decide to run color at this point, it's lowercase, it's taking this last one here and running it. It has not been saved, really. We're just taking a look at the loop for right now and kind of the way it works. So here's another example of capitalization. Taking a look here where we're gonna do title case. So you can see it's running through and doing each of these and putting it into color, and we're printing it out for each one. So this is one run through the loop, where it's saying, okay, I'm going to go in, I'm going to take red, I'm going to make this one title case, I'm going to print it out, I'm going to come back in, blue, and then green. So for each of these, it's doing that. We're going to use count to see how the loop works, kind of break it out a little bit further. So for this one, we have our container here, we have a list of 1, 2, 3. We're going to print what is in here, and then we're also going to print yes times what is in the count. So, and then we're going to print done counting. So if we run this, so we have the 1, which is printing what is in the count, and then it is taking yes times what is in the count. So we get yes printed once, then it goes back in, it goes to 2, goes to 3, and then it kicks out of the loop. You're familiar with if then else's. So what I'd like you to do is do a little stretch here, and in your own words, write what's happening below. Next up, we have another exercise here where you're going to run the code below. And why did the second loop not bring back the entire phrase is the question. And then you're going to change the code to bring back the entire phrase. So this is what we have. And what is this doing? And how do you fix this? Why is it doing this? And how can you get it to bring back the entire phrase within the letter? So for this example down here, it's a little bit separate. What we're going to do is we're going to take this little string here that says loops iterate and load it into a variable called loop. And so now we have this loop down here. So this should say loops iterate. We'll load it. You can follow that along, that this is now going to have loops iterate within here. And so for the letters in loop iterate, what it's going to do is this is empty. It's going to go in and it's going to say if the letter is equal to I, then print the letter. So it's going to go through and print out whenever we find an I. So if we run this, we should see that we have an I. So if we just for funsies put an I here, we get an I as well. So it doesn't bring back every single I. It just is going to, if there's a letter I, it'll stop and print that one out. So I want you to think back to that list of family members that you created in the dictionaries and lists and try using a loop to put all of their names in uppercase. There is a bonus here to put the entire loop in a function and call the function, and then also playing around with using input prompts to make this more dynamic, and would use pseudocode to help in design and planning. So yep, this is a little exercise where you can pause and go back to that unit and say, okay, this is my family members exercise where I've listed my family members, how would I actually put this in a loop, and then update them to be all uppercase so I don't have to manually do them to uppercase. If you're struggling at this point, I mean, it's probably simple to follow, but independently doing it, if you're struggling, manually do them uppercase and realize that, hey, there's got to be an easier way, and that'll be a good motivation for digging into loops and understanding them a little bit better. Next up, we're going to go down to ranges. I want to encourage you to hopefully have paused and done the previous exercises. So we're going to go down to ranges here. What a range will do is this is going to give me a list of numbers. So here we've got a range of 4, and we're going to load this into a list. Here we have a range of 10 that's going to be loaded into a list. So we can run that. We can see this is going to print out 0, 1, 2, 3 because it does start counting at 0. And you guessed it, this is going to go to 9. So this is essentially like, what does this have to do with loops? Well, we're going to be using ranges in loops to kind of control how many times we want it to iterate through, and we can use ranges to do this. So in this one, we have a range that's going to be 6 long, 0 through 5. We're going to load this into n. Clean this up a little bit. All right, so we've got a range of 6 that we're loading into this identifier n, and then we're going to run this for loop, which is essentially going to do what we saw up above here, where it's just counting and going through a count. But this time, instead of actually having a number here, we're going to have this range that's loaded in from this variable. So let's run that. We can see we've used a range to do that. So moving down here, we're going to see a kind of fun little example here of an 8-hour day of work. So for an 8-hour day of work, we're actually going to be going 1 through 9 for 8 hours. And when we go into the loop, we're going to start the hour. Towards the end of the loop, we're ending the hour. And when we end the hour, we're going to go ahead and print the count that we have. So we're going to put it as a string and concatenate that with hours so we can see how many hours we've worked. Once we've worked the full 8 that's in the string, it's going to print out, go home, you've worked a full 8 hours a day. I would not expect this to print every single time. As you can see, it's not going to print until we're kicked out of the for loop. So let's go ahead and run this. And we have a syntax error. The reason why we have a syntax error is this is one of my older examples, and I've yet to update it to Python 3. And as a matter of fact, I have updated this. I just always update it live in class because I keep forgetting to save this update. So let me go ahead and go up to this really hard function here, this little save. I won't have to keep updating that. All right, and then I probably need to fix these as well. Still have an invalid syntax here. It's fine to show error messages. You can see how I troubleshoot them. You're going to get error messages. They're not going to always play out perfectly the first time. Looks like I'm getting another indicator here. Invalid syntax. This seems like this should be good, but let's see what it brings back. Oh, it works. So I don't know why that's giving me an invalid syntax. All right, so we've got the start of the hour, end of the hour, then it prints out 1 hour, start of the hour, so we're back in the loop. Start of the hour, end of the hour, then it prints out 2 hours. So hopefully you're getting a sense of what's going on behind the scenes in the loop, because sometimes you're not going to get all these printouts, and I just want to show, okay, this is the anatomy, the engineering, the physiology of the loop behind the scenes. Next up, we're going to do a random integer. So this is another function that we can bring in. So we're going to be using the random library and bringing in a rand integer, which will essentially give us a random integer. And in this case, we're going to be trying to do a coin flip. So it's going to choose between 0 and 1, and it's a little bit of a simulator here. So here we were going to do 100 flips, and we're going to use the random integer. We could do more than 0 and 1, but we want to do a coin flip, which is going to be a heads or tails. So we're going to do a random integer, either 0 or 1. What I'm doing here is something a little bit different. I want you to see we've got a for loop here, and I actually have a for loop here as well. This is comprehension, and as I've done throughout the entire course, I'm essentially giving teasers into things that are coming up. I realize this is the last unit in Python for Data 1, but there's a Python for Data 2 and a Python for Data 3. So the idea here is you have a comprehension where we're kind of compressing down, sort of like what we did with those math compressions, this for loop, and making it a little bit more readable. So in this one, I'm going to say, I'm really just taking this and putting it on like one line, where I've got the number here, which is 100. That's going to be my range. So it might take a second to kind of look through exactly how this is working. You could split this out and actually not have it be on one line, but I did want to kind of show that. Coming down here, so we've got two loops happening. Down here we have a result that is a list that is empty. And essentially I'm taking the flips here. So I'm taking all of these flips, and with those flips, I'm going to say, okay, I've got this object, which is going to be blank. If the object is a 0, then the result is heads. If the object is 1, then the result is tails, and we're going to print the results. So this first loop here is doing the simulation for me, which would bring back a bunch of 0s and 1s, unless I had actually done this other loop here, which is let's translate those 0s and 1s into heads and tails. So let's see what happens when we run this. We get an error message, and why? Because I forgot to update this as well. I'm tempted to restart the video, but I think that this is fairly simple enough on printing these results out. Print like that. Okay, so let's go ahead and print it. There we go. So we have all the tails, all the heads. Now here's the challenge. Can you count how many flips were heads and how many are tails? Can you create a calculation that displays the percentage of times it was heads to tails? This is a challenge for sure. Don't feel like you have to do this right now. It's not an exercise. It's a challenge to come back to stretch yourself a little bit. If you feel like you need to go out and take a look at some code, obviously you can find some examples. Just make sure you understand the code and what it's doing, and maybe get it to work and then delete it and see if you can figure out how to do it. This is for sure a stretch. Heading down to loops and lists. In this situation here, I'm going to take this list and I'm going to put it into something called counts, and I'm going to take a bunch of lunches here that I like and put this into lunches, and I'm dating myself here. This is out in Issaquah for anybody that knows my work history. Right here we've got change, so we have different types of data types, integers and strings. So we're loading all these into some lists here. So we got a list for counts, we got a list for lunches, we got a list for change. Then we're going to do a for loop. So we're going to count. We're going to have this blank container here that's going to go into counts and print out all the counts. So let's see what that looks like. Okay, pretty straightforward. Next up, we have an I for iteration. I like to call that for the iteration. And we have lunches here. And what we're going to do is we're going to do a print statement. And this is kind of old school, the raw inputs. So it's going to be a string, and we're going to load this into there. So we're going to take this I, which is here, which is coming from lunches, which is up here. It's going to load each one in and say the lunch options are, and it should kick those out for us. There we go. So it's running through that loop. It's saying, okay, this is blank. Let's go into lunches. Let's take the first one, tie. What are we going to do with it? Lunch option is tie. All right, are we done? Nope, we got another one. So we're going to keep doing this loop until it gets a sandwich. It's going to print that one and kick us out. Yeah, it's going to do the same thing for change. Fun little refresher. Can you change this without looking to format using the format insert method with the squiggly brackets? You'll get a couple error messages. It's not the end of the world. See if you can do that and try to build another for loop down here with a list. Next up, we're going to build a list from a loop. So here we have some values. We have a blank container for a list. And we have a for loop here. You can kind of follow along if you've done strings and lists already. This is going to append to what is an I. And then obviously this is going to go back in and write into the values. So we should be able to build our list this way. So we'll go into I, we've got the range. It's going to go around about 6 times. Each time it goes around, it's going to say, hey, in the values, let's go ahead and append this based off of what's in I here. So if we run this, adding 0, 1, 2, 3, 4, 5 to the list, if we go out, whereas before, remember when we did the uppercase for the colors, it didn't really hold those values. Now it will hold the values, so we could print values. And it's holding those values now, so hooray. Now what I'd like you to do is to create a random list of numbers, bring back only the odd numbers, and write it into a separate list called odd. This is doing some recall to a couple of things that you've done so far. You can use math to get the odd numbers. You can use maybe stride. You can try a couple of different options that are not just in this unit. Another exercise here is document what each of these are. And here's an example where maybe some inline comments are okay, because this is mainly for learning. How would you put this into your own words to explain exactly what every piece of this is doing? And then maybe how you might make it even better. All right, so next up we're going to go through iterating over a dictionary. Here I've got some channels, TV channels. I've got the TV names, and I've got the channels over here that I'm loading into a dictionary. So when you're reading this for loop, the for loop is really here, which, you know, when you're seeing all this jazz down here, it can get confusing, like what's going on with this. Well, this is just kind of the old school way of inputting information into a string statement. So remember, we have our string here. We have a decimal here, which is going to correlate to what's going on over here. So this C is saying, okay, well, what the heck is the C? The C is going to be the key, and for channels and C, that's going to be the pair. And if you're maybe a little bit confused on that, you can revisit the dictionaries course, because you know, it takes a few times. That's why this class is designed to be a loop. But essentially, this is going to be the key that'll print off, and it'll go into here. And this will be the values for your key value pair that's going to go over here. So if we run this, should see that this works. Fingers crossed. There we go. MTV is on channel 35. All right, heading down. We've got this performing an action after each iteration. So for this one, we've got daily revenue, and we have some money, and then you know, this is a Monday, this is a Tuesday, Wednesday, Thursday. These are not printing out. These are essentially just some notes for myself. And yet again, another broken rule of an inline comment where maybe it's okay. Maybe we can fudge it a little bit and say that this is okay to do inline. Going down to our loop, we're going to have a total that starts at 0. We have a container of day, and in the daily revenues, what we want to do is we want to do the total plus the day. So we're going to keep iterating on that. And then we kind of saw this before when we were doing averages over our scores. So this is essentially kind of the same idea. Then we're going to take the total, we're going to take the length of the daily revenues that we've actually collected, and we're going to get the average from that. The other thing that we're going to do, this is when it's kicked out of the loop, by the way. We're going to print the weekly revenue. We're going to print the daily average. So if we run this, we see that we get the weekly revenue, we get the daily average revenue down here. So these notes are just for me on the actual day names, but you should be able to read through this and kind of understand what it's doing. There's nothing in here that is different than what we've kind of covered up here. It's just another example. Maybe just a little bit more practical. Down here, we're going to be using the reverse function, so you can start at the last position and work backwards. This can be helpful because sometimes you need to do comparisons from top to bottom and bottom to top. So we've got just a couple of lists down here, and what we want to do is go backwards in it. And how we're going to do that is, let's go ahead and run this. we can see, okay, we got Biffle, Boyer, Bush, Gordon, Patrick. And if we want to print them in reverse, all we really need to do is use this reversed function here. So it's going to go in reverse, and it's actually going to say, okay, take this names, which these are the names, and do the same thing but in reverse, which is maybe a quick and dirty way of doing a sort as well. So it reverses it. I have an exercise down here for you where you're going to write an expression to print each price and the stock prices. Here's the sample output that we're looking for. So when you're done, it should look like this. Your solution will go here for your for loop. So it's a good place to practice. So see if you can get the stock prices to actually print out and look like that. Next exercise here is working on printing a dictionary. Here we have a whole bunch of emails, and what you're going to try to do is actually print these out. So you're going to create a for loop that will print out the emails in the dictionary, and so it should look something like this when you're done. That should be the output. Pause the video now and try working on that. All right, next up we're going to take a look at the while loop. I just kind of want to jump into it and take a look at the expression because I think this can kind of be a little confusing and you might just want to see it at this point. So the syntax of it is we're going to have an expression. We're going to end that expression with a colon. Then and this expression, by the way, is essentially the criteria of what's going to kick us out of the loop. And then here we're going to be doing something while we're in the loop, and then we're also going to evaluate whether or not this is true or false that will kick us out of the loop. So here is an example of this in play. Here we've got a variable x that has been loaded with the value of 3, and the first piece of this while loop here is saying while x is greater than or equal to 1, we're going to do something. So notice that it's kind of the same. So we've got some sort of loop expression that says, hey, I want you to do this loop while this is in play. Next, we're going to do something. So we can just say, go, no go, something like that. I don't know. So it's going to print this each time. And then the evaluator down here is essentially going to say, okay, well, if x, well, first we're going to take x, which is right here, which is 3, and we're going to subtract 1 from it. And we're going to load that into here, which now becomes 2. So then 2 pops up into the loop. Remember, we're not going back outside now. We're inside the loop. So 2 is going to be here, and it's going to try to evaluate this and say, no, hey, it's still equal to or greater than 1, so it's going to run the loop. It's going to subtract 1 from 2, which now puts 1. It still should run. It'll go again. We should be at 0. It's going to kick us out at this point. So let's go ahead and run it. And sure enough, go, no go, go, no go, and then it kicks us out. So here's some more examples. And what I want you to do as you're looking at these examples is, yes, you're trying to figure out the syntax of the while loop and the logic of what's going on in the while loop. But first, identify, okay, this is the expression that will be deciding whether or not it's going to be kicked out. This is what it's going to do while it's in the loop, however many times it goes through. When this evaluates to a certain criteria, it'll kick into here, which will kick us out of the loop. So that's what we're looking for, is the expression, what it's doing, and looking to see when this will actually kick into here and evaluate to true, which will shoot us out of the loop. So you don't even have to really read the logic. You can kind of go through these and just identify those pieces of it and where those are at. With that, let's go ahead and go into this first one. We're going to do a list of numbers. We have an iterator of 0. And we're going to say, well, I, the iterator, is less than 4. Let's go ahead and print what's in the list. And then what are we going to do to I? Well, we're going to take I and add 1 to I. So this should go to 1, 2, 3, and once it gets to 4, it should probably kick itself out. So let's go ahead and run this and see if that plays. Yep, 1, 2, 3, and then it goes up to 5. I'll let you kind of noodle through why it's going all the way up to 5. Remember your Python indexes. I don't know if that's a hint so much as an answer. All right, coming down here, what I have very cleverly done here, if you take note, is asked why this is different than this one. So I'd like you to go through and kind of take a look at these two. They look almost identical, but I want you to look at, okay, what's actually different in it? Why is it different? And does it actually make a difference to have it to do it this way? One of the dangers of the while loop is having it just go on into infinity, as we'll see with this example here. So I'm going to run this one, and notice it's just kind of running and running. Nothing is outputting. I don't have any output. It's never printing an average. And if I let this go for too long, my computer will start just whirring and whirring and whirring up a little bit. So what you can do is you can Control C, or you can right click and restart your kernel. Whenever you restart your kernel, it's going to blow out any of your variables that you have set up, any of your imports that you have done, but it'll save you if you ever have a while loop that's just going on into infinity. What I'd like you to do is just take a moment, pause the video and take a look at this and see if you can figure out what's going on that's wrong with this one. If you want to type this out or work through the workbook to see if you can solve it, now would be a good time to do that, and then I'll show you the solution. Okay, so the solution for this one, if we take a look at it, we have a sum that is starting off at 0, we have a num that's starting off at 0, we have a value that's going to be starting off as 5, and while the value is greater than -1, then it's going to actually do this work for us. It's going to take the sum plus the value that's in here, it's going to take the num plus 1 and add it into here. So these are iterating and these are growing by 1 or by what's in the value. Next, what it's going to do is after it goes out of that loop, is we're going to ask it to take the sum divided by the num to give us the average, and then it's going to print that out. Now, we never actually really got to this stage down here because we needed to do one other thing, and that is this value is always staying at 5. We don't have any control to move this value down, so it's always going to be 5. It's always going to be greater than -1. So what we need to do is take a val and take this and do a 1 there. So what this will do is it'll take the value and it'll actually subtract 1 from it each time it goes through the loop. Now when we run this, it should just kick us straight on out. There we go, 2.5. Anyways, that's a little bit on being careful with your whiles, because they can just run out of control. And when they do that, you can do a Control C or restart the kernel. And you really want to make sure that your condition that you have set up here has some sort of control that you have tested that will actually stop the loop from happening over and over and over forever. Coming down here, we have an exercise for you to try out. So I'll let you read through this and you can pause the video and work on this exercise. Okay, so here's an interesting one that I put together during review time at Costco. So we have an example here where your boss is working on your review and it is starting out as true. And while the boss is working on a review, heads down, complete a task. When the task is finished, see if they're gone. It's Friday. You want to get out of there, right? And so we're going to put the counter to 1, and this count is representing the task that you've done. So we've started off with 0. We're going to complete a task. Take a look, head over the cube. Hey, is he or she gone? Let's get out of here, right? Kind of a thing. And so it just keeps doing the tasks in there. And then as we go into here, we're going to count the tasks and just say, hey, well, on top of that, great job. You've completed like 4 tasks or 40 tasks or whatever. And then down here, I think we have this extra print here that isn't needed. And then down here, what we're going to do is we're going to establish if the boss has left or not, because when we have this random range here between 0 and 10, which we know is 0 and 9, and it's once it equals 0, so it's going to, every time it comes in here, it's going to give us a random range. It's going to say, okay, you're coming down here, and now it's a 3. Next time in the loop, now it's a 2. Next time you come down here, it might be a 3 again. And it's just very random each time. When it actually hits 0, then the boss is still working on a review. It will be changed to false, and it'll say, print, go home, you hard worker, your boss is gone, yay. So that is this loop here. So if we run this one, we can see we completed 4 tasks, 12 tasks, 3 tasks, 16 tasks. So we have a random generated event that is going on 23, 7, 18, 6, so on and so forth. So hopefully you're getting familiar with reading through loops, for loops and while loops, and understanding that whenever you have a while loop, you want to make sure that whatever it is that is your while, so the boss is still working on the review here, is set to true. You have that controlled so that at some point it will turn off. If you don't have it turning off, again, it's going to run forever. So you have an exercise down here that you can do, which is it's an exercise where you can create a bot, a chat bot. So I'll let you pause the video and you can take through this exercise and play around with it. This is a pretty fun one. And after that, there's also a bidding exercise that you can take a look at. So I'll pause on both of these for you. All right, so now we're going to take a little bit of a closer look at counting. We've already been doing a lot of this. This is just showing you a couple of tricks and just some reminders. So in this one, we're establishing an iteration where this is a 1, and we're going to see that this will actually continue to iterate. So we're going to take I plus 1, and it'll add it to I, so we'll see this grow. And a thing that people usually forget to in their loop is to remember to have this control in place. So this number right here, we talked about this already a few times. I just can't drive the point home enough, that you want to make sure that you have something established in here so that your loop will complete. So again, if we run this, this will actually, we can print out I and we'll see that it completed. Yeah, sometimes I break my own rules and I'm not being explicit, but what are you gonna do? There we go. All right, coming down here, we're gonna do a countdown. So here we have the 5 is being loaded into I, and while I is greater than or equal to 1, then this is going to run where it'll actually do a countdown, and you can probably read through this and see how this is going to play out. Here it's doing an iteration by 2, so if you need to iterate by 2 up to 100, hopefully at this point you're getting a little comfortable with reading these, so I won't break these down completely. Going over a US presidential year election, you can go through this and actually establish these years and set these up. So this is a little exercise for you. So I'll pause here and let you play around with this one. Next down here, we have a printout where this is what you want the results to be. I've started it out for you here. So if we run this, we have an error that comes down, says numprinted is not defined. So you have to go through and figure out, okay, how is it that I'm going to set up this program so that I get this output? So pause the video and let you play with that now. The next thing that we have here is a little summary on loops and lists, because you're going to want to take your loops to update lists. I would say at this stage, you could probably go through and find some content online and have enough of the structure vocabulary to do this. We do cover this in the next set of courses, Python for Data 2, but I just want to make sure that everybody feels very confident at this level, understanding a loop, understanding what a list is, understanding what a dictionary is, and we will dive deeper into these iterating over a list, iterating over a dictionary, nested lists, so on and so forth. So this is coming. For right now, a good place to be is to be practicing what you have learned and get confident at this level. And definitely don't wait. You can go out and start Googling and looking around on Stack Overflow, YouTube, all around to find out more information about these. And then finally, we have the project exercise that's coming up where you can review some of your scores. You can definitely do some loops over these. If you're trying to update a list or if you're trying to read listen, it may be a little bit frustrating if you're like, well, I don't have the full content here and it is coming up soon. Again, don't wait. Just start playing around, practicing, stretching yourself a little bit, and don't let what you know be a limitation for what you can do. There's a lot of stretches when you get into coding, and this would be one of them. What is it that you actually want to accomplish? Now, how are you going to accomplish it? So with that, good luck. And I do have one other thing coming up that I was inspired to put together, and that is just a real tip of the iceberg, applying what you've learned to Excel and applying what you've learned to SQL, and then we'll be off to Python for Data 2. Thank you so much.